It's a result of lessons learned. I mean, we have been doing research in smart cities and also urban digital twins now since 2008, something like that. So it has been quite a long time. And the term urban digital twin only came up and was established rather over the last maybe 4 or 5 years. So it's rather a younger definition. But anyway, the question is now for people who are going to start and set up and are starting an endeavor to build up urban digital twins, what are key takeaway messages? What do you have to keep in mind? And I think, first of all, I mean, that's something we have seen today already, and these are models, and especially digital models of the physical environment. And one of the important lessons learned is there is not a one model fits all. So it basically means we have different kinds of 3D models, and they can afford different purposes. Some of them can directly be used for certain purposes, some cannot. And some are easy to generate and fast and highly automatic, and some are quite expensive. So you can see, for example, these are the 4, I would say, mostly used kinds of 3D models today. And I start with the bottom row, and this is just barely 3D point clouds as being produced by mobile mapping systems, by drones. The good thing is this is 100% automatic. So it really means you can fly with a helicopter, with a drone, you can use a laser scanner, and you can directly produce this, even also with colored points. That's the nice thing about it. So it means it's rather cheap to generate, it's rather cheap to update, and it can be done very quickly. And so it means you have up-to-date data of your environment. But, I mean, for the human, it looks like a city. But for the computer, that's not so easy, because if you would ask how many buildings do I have here, how many traffic signs, how many driving lanes do I have, what's the speed limit in the middle driving lane, that's all not to be answered. I mean, just for the human, you can look at it and see, okay, I see a building here, I see a tree. So it's already, for certain kinds of applications, quite useful. Also for change detection, for example, that's quite useful for that purpose. What you can typically do, you can mesh these point clouds, and then you end up with a mesh model. And that's basically what the level is that Google offers today on a global scale, what Microsoft and Apple offering today. And that's basically simply, you could say, a blanket that is thrown over the landscape. And typically this is textured. And we have seen also examples today, also from Helsinki, but also from other places, where you see that basically represents the spatial characteristics quite nice. And then, however, on the top we have, that's a different class, you could say, of models. And they are the so-called semantic models. So that means, in this case, maybe the geometry looks a little bit more generalized, or maybe a little bit more detailed on the top right. But that means basically everything that is represented in such kind of a data set is represented as a building, as a road, as a tree, everything. So that means every object knows what it is. And we have basically 2 different scales, you could basically say, or 2 different approaches. On the top right, you see building information modeling, which is basically the idea of digital representations of infrastructure and of built constructions, and mostly has been created, at least originally has been created, for planning and designing and for building of constructions. And on the top left, this is basically semantic 3D city models, which takes a look at the entirety of the city, including vegetation, including also natural water bodies, including the terrain, the relief, etc. And so basically is addressing, you could say, basically the entire city, but in a more highly generalized way. And one lesson really is, in the end, you will probably not end up with one model of these kind ruling all the others and saying, okay, I just get away with one of those. And in the end, you will typically have to find ways in your projects to deal with the different kinds of representations. And sometimes, of course, there is big research going on for many, many years, for 30 years at least, to come up automatically from here to either there or there, but this is still not commercially really a fully set up process. So there's no 100% solution, putting in a point cloud, getting out a BIM model or something like that. That's people are working on it. There are products which can do a semi-automation, which support you in these kind of things, but it's not yet there. So even with today advances in AI, there's still a lot to do. Okay, but now the question is, just a short review again, and also here we have standards, and that's quite important on the side for the BIM. We have the international standard IFC, and for the city models we have the standard CityGML, and I am also happy to announce, but I think everybody probably knows that since this year we have CityGML 3.0, the data model and the exchange format being standardized by the OGC, so that's also quite a nice development. Okay, but now, is it this? Because when you talk with people and about digital twins, they say, yeah, we created a 3D model and that's the digital twin of our city, of our country, or whatever. Of course, no, the answer is not. And the only thing that I've presented so far were just the digital models of the physical environment. They are an important key element. And if everybody, because also I had a lot of discussions in the past with people from the smart city domain, and they say, sensor data plus AI, that's basically what we need, and maybe a decision support system to have a smart city and possibly also to have a digital twin. And they're completely missing the entire digital representation of the space. So that's also something I would say, no, that doesn't work. So these are one key element. But of course, what about the actors and stakeholders? And of course, the use cases the stakeholders and the actors have, not addressed so far. The processing and the analytical tools and the simulators, all kinds of simulators for all kinds of domains. Real-time measurements and using sensor devices and sensor services, for example, not covered so far. And the many different sectors and thematic domains. We have seen them in the presentation. So we have mobility, we have environment, we have the financial sector, all kinds of important sectors, also not yet addressed. So that means all of these kind of things need to be addressed. And so in the end, the urban digital twin, you can say, is a set of all the digital resources about the city, which are distributed across all the resource owners. And so it's, I'm talking here not about mostly a centralized managed thing. I mean, there can be something like a curated digital twin. So if, for example, the City of Munich says, we are maintaining a digital twin, then it's basically that part where the city takes responsibility of the data set of the infrastructure that is provided by that. But in the end, a digital urban twin is something that is open in the end, because maybe every citizen who owns a sensor and a weather station and puts it up on the web is contributing to it, even maybe if he's not visible on a certain platform. Okay, so but clearly this entire thing cannot, in a comprehensive way and in a fully closed way, can be represented in a platform. So our conclusion is we need an infrastructure for that. So and an open infrastructure where people can connect. And I think we have seen good examples today from different places how this can go on. And I mean, if you look at the city is a complex system. First of all, we have maybe completely different stakeholders. So you need to be, when you start building up your digital twin, it's not sufficient to think about the perspective of the municipal administration. You also have to think about what about the utility service providers, what about the real estate firms, the citizens, and the transportation providers, for example. So you really need to be aware that there are these different kinds of stakeholder groups, and all of them have interests, but they also have something to share. Second, then, we have their applications and their needs. So basically, you can say, okay, some of them, for example, the real estate firms, they were interested in energetic building refurbishment, for example. Some are interested in crowd management, maybe if you're managing the security along Oktoberfest, for example. City might be interested in air quality monitoring, etc. So you have this is just examples of kinds of applications. And then we have the different kinds of tools. And these tools are not the applications. These tools are just building blocks. So you use them in these applications. So for example, if you have a flood simulation software, it's typically a highly specialized piece of software, not usable for a citizen. So if you want to have something like an application that is usable by a citizen, you have to encapsulate it in an application, and that application maybe calls then the flood simulation to be run with certain parameters, etc. But then the result again is being transported via an application to your stakeholder. So that means also, again, we have a huge set of different of these kind of tools. And then finally, we have all the data. And we have different kinds of data. And you can possibly see, of course, we have the 3D city model, or maybe also a two-dimensional city model that also can be used. But then we have all kinds of remote sensing data. So satellite sensors is just here a placeholder for all kinds of remote sensing. And that can be from satellite, can be from UAV, it can be from a mobile car, it can even be somebody carrying a backpack with a sensor in it and basically sensing the environment. But we also have what is shown here, weather sensors. That's also just a placeholder for all kinds of in situ measurements. And that can be every sensor. It can be a traffic counter loop in the ground. It can be a temperature sensor in a room. It can be the temperature sensor in the city. So basically, we have all these kind of things from all these different domains. And you can see this is already creating a little bit of a mess. And that was basically the reason where we started many years ago on defining a framework. And Mandana is sitting here in front, and she gave the presentation on behalf of the City of Munich. But she's one of the originators of the following concept, because we rearranged things and tried to come up with a diagram and with an idea and with a structure that helps us to get a little bit more a clearer overview of all of this. And that's basically what we call the Smart District Data Infrastructure, SDDI. And what is that? I mean, it's simply a concept, mostly an organization concept. We are not reinventing technological things. We are not reinventing something. It's more like the idea how to approach this kind of complexity. First of all, on the one hand side, you need to think about your actors, and you need to engage them. That's always important. You need to understand the use case, because that's where the added value is and where the money comes from for doing these activities. So then, their problems and their tasks are typically solved by using applications. And we have a whole array of applications. And that array is not offered by one vendor or by one company or whatever. This is an open collection of tools that basically can be created in the future to basically establish the added value for the shareholders. And then, of course, we are looking at more data-related things. And this entire sector here is about data. And it has 3 sectors. That's quite important. The first sector is the one in the middle, and that's the digital model. Why did I explicitly mention this here as a sector? Because these digital models of the environment, they really can serve as a connection point between all the different other kinds of data sets that you have. We have heard from Munich, for example, that the building register, building information is quite important. You have energy demands for the buildings. You have maybe the ownership information and the cadastral information related to the building. You have information about the numbers of flats inside the building, but they are all distributed over many different places. But the digital model can serve as the anchor point for every of these different groups to connect their information to it by simply using the same identifier, the same object identifier, and then basically this is a really, really important and strong point. That's the reason why I put these virtual district models, including also BIM, here in this sector. And then, however, we have on the right side, I would call that static data. Static data, but that is also distributed over all the different thematic areas. It can be data on mobility, on unemployment in the city. It can be the information about energy certificates of a building. These are typically not changing every minute or something like that. So this data is typically there as a file, as PDF, as Excel, as maybe also an entry in the database, whatever. So that's all here. This is not stored. I mean, this is not a diagram about how to store the data. This is not central, one platform or whatever. It simply helps you to organize the different things. And then we have the real-time or near real-time data, which is basically, you can basically say one part of the data is coming from remote sensing, the other part are in situ sensors. Why is that important? Because you only need one standard to cover all of that. For example, just an example, there are other standards, but from the Open Geospatial Consortium, there is a standard called Sensor Things API, and that is capable to map all the requirements of this on the top left. you can access remote sensing sensors, you can access traffic counter loops using the same kind of protocol, using the same kind of data format. And that's basically, if you have a solution for that, it can be used in mobility, it can be used in environment, it can be used in all these other aspects. That's the reason why I believe this makes sense to keep that represented like this. And this kind of data, this is typically being served by already existing urban data platforms, or by open data platforms, or by web services like the Web Feature Service or Feature API or whatever. So there are many other open standards that you could use to offer access to these kind of things. Okay, and then we have, no, wrong, this one. And then we have the Urban Analytics Toolkit. So that means all these kind of computational modules where people say, okay, that is not intended to be presented maybe to the citizen, but that is important and a key element. And here basically AI-based methods, but also non-AI-based methods can basically be put here. And this is again, not a centralized implementation. This is simply a call to say, okay, we may have a collection in the end of all these kind of tools, and some are provided open source, and some, however, are being offered and operated by companies or something like that, but they all fall in this category. And what is, however, missing is, who knows what's available? And that basically brings me to the last part, and that's the catalog. And the resource catalog is, from my perspective, an important, and that's really one centralized piece. That means everybody who is offering something, either an application, either some data, some analytical things, some data sets, etc., they should all be announced somewhere. And that catalog, however, should not be operated simply as a closed system, but it should be open. As many different companies, different citizens should be able to add and contribute to this kind of thing. And and the important thing is, of course, for all of these things, they must be interoperable. So you need to support open and standardized service interfaces on the one hand side, and on the other side, of course, for the different kinds of data that is represented, you should, of course, entertain and use internationally standardized data models and data representations, because that allows you, in the end, that from the city of Munich, some data can directly be consumed on the platform, like, for example, from Utrecht, and being presented very easily, very smoothly. And so you can really save your investments, and also for companies, you can sell the same kind of software solution to many different cities and to many different use cases again. I'm nearly through. So, and that's basically also the idea. Don't copy all the data together, but rather say, I have here an application, and that kind of application on the one hand side uses the catalog to find out what are the offerings, and then basically at the moment the application needs the data, it will query the different kinds of services, and they are operated by completely different stakeholders. That can be open and municipality data sets, but that can also be data offered by citizen initiatives, but also by private companies. So the idea is really having an infrastructure, and that is already there. There are spatial data infrastructures, SDIs today. And that's also my point to say, I'm professor for geoinformatics. And that's basically, I say, we have a long year tradition, 20 years experience on dealing with that kind of stuff. And so that means if you're going to start building up these kind of digital twins, you should probably ask in your city department, those people who are already familiar with that, or also others, at least have them on board. Okay, then. Just one word on the catalog, because that's something also I have a concrete offer for you, because we have been hard working on developing an open source implementation of this kind of a catalog. And you can download this, and the catalog here is basically it's open source, it's based on the CCAN open data platform, but we have extended it quite much. So, for example, we have spatial and temporal metadata, so every entry in the catalog can have a spatial component, can have a time component, and then you can search who did what kind of project on smart lamppost in Bavaria in that time period, for example, and then it will give you these information. The catalog does not only register data sets, but it registers, as you can see, digital twins, projects and sub-projects. So you can even enter a project that is currently ongoing in your city and say, this is the sub-project. who are the involved stakeholders, where is it running, and then, however, you can also register individual things. So even one smart lamppost can be registered as a single entry in the catalog, and that can be linked with the project, and that can be linked with a digital twin. So basically, you can easily manage all of these things. Geo-objects, method, software, online service, online application, and finally, what everybody probably would expect, data set and document. And all of these things can easily be registered using a graphical user interface that should be easy to use. And we have now really implemented it. It's production ready, and it's already being used. And it can easily be used and deployed in cloud environments. So because the CCAN software consists of a number of different software elements, including, for example, PostGIS as a database underlying, but there are many other parts. And for that reason, we have also created Helm charts that you easily can deploy that in cloud environments. And by just one command line, I can start the entire stack. For example, running on my own computer in Docker desktops, or for example, that's if you want to experiment with it, that's very easy. But of course, we are also currently running instances on Azure Cloud and T-Systems Cloud. And so if you're interested, have a look at it. And here's just finally an example of this catalog. And here's a link to a running catalog here for a project where you can also see that. I think we will distribute the slides afterwards to all the participants. So if you basically did not get the links, then this should be fine. Coming to the end. One more point. We are currently rolling out also the SDDI concept in Bavaria, and there is a project that's called TwinBuy. So that's digital twins for Bavaria, and it's funded by the Ministry of Digitalization, and we have 18 municipalities, especially also smaller ones, not the big ones like Munich, but also the smaller ones, and that can then profit and benefit from these kind of tools. And here you see what is being offered, and especially qualification education, service time from IT companies, but then also there is open source software like the catalog, but also diverse commercial applications, but these depend on the use cases of these different 18 municipalities. So every municipality comes up also with their use cases that are going to be implemented there, and that's basically some support going on for that. So if you're interested, also you get more information here. That's my final slide. And basically, the question is, what are now the key elements of digital twins? And this is, of course, not, I would say, the full list. But I would say you should probably not leave out one of those points. So I think this is rather a minimum list, I would probably say. So you have to take into account and be very clear about the stakeholders and the actors. And of course, every stakeholder can work as a consumer, as a producer, or as a prosumer. So cities typically are prosumers because they are producing data at the same time they are using them. So that's also an important point. Second, we have distributed digital resources. And there, one important thing I mentioned in the very beginning, digital models of the physical environment. But then we have dynamic data from all domains, static data from all domains, analytical tools from all domains. So you really have to think about how to manage that in an interoperable way. Because interoperability, that's also one of the key messages here. And the joint catalog, which helps you to get informed and get everybody knowledgeable about that. And finally, of course, digital twins is not just about technology, but it's about an organization and an operational framework. So it means we have the spatial data infrastructures, and the institutional background are good starting points. But they are existing, and they are sustainably operated. They are typically funded also already. So it means there's a lot of data, there are a lot of service, there's a lot of knowledge. You should also benefit from that. And one possibility to go forward is extend spatial data infrastructures to become spatial smart district data infrastructures in the end. So that's basically my final message, and I hope you enjoyed it. And yes, we will have also one of the Barcamp topics we are offering is about the catalog and of the role of the catalog and what possibilities there are for catalogs in digital twins. So that's one topic and we can offer. Thank you very much.